features and services are easy to use. We have what we call the well-architected framework. And in this well-architected framework, we say that operational excellence and security are top priority. That is why those two elements or pillars are the first, and the others are also important: reliability, performance efficiency, cost optimization, and sustainability. But when we say security is our top priority, we say that and we implement a lot of services and features. There are more than 500 services and features just about security in Amazon Web Services, AWS. And one of the ways we can group these services are in the epics of the well-architected framework in the security pillar, which are identity and access management, detective controls, infrastructure protections, data protection, incident response, and compliance. And it's not just that we in AWS said security is our top priority. We also have more than 200 certifications and accreditation of security and compliance, which means we passed more than 2,600 security controls in which we are audited annually. So it's not just that we say security is our top priority. There are also other entities and organizations which audit us to confirm that commitment with security. Other way we can group security services is telling first about security monitoring and threat detection, then what we call data protection, which is mainly the capabilities to encrypt data at rest and in transit. And also our topic for this session, which is protect and defend cyber resources, in this case, specifically networks and applications. But let's start by seeing what are the main risks we face when we want to protect our networks and applications. We can classify security risk in 3 groups: denial of service, application vulnerabilities, and bad bots. There are other ways to classify them, but we can propose these groups. And let me tell you about first what are SYN float attack. In this attack, the attacker sends a succession of SYN requests in an attempt to consume enough server resources to make the system unresponsive to legitimate users. In reflection attacks, the attacker exploits vulnerabilities in DNS servers to turn initially small queries into much larger payloads. And in web request flows, the attacker uses sophisticated layer 7 requests with excessive payloads, but which look legitimate for the servers. In the application vulnerabilities group, we have first attacks like SQL injection, which uses malicious SQL code for backend database manipulation to access information, cross-site scripting or XSS, in which the attacker uses malicious scripts that are injected into a trusted website. Also, we have other vulnerabilities and exploits, which are in the Open Web Application Security Project, or OWASP, which is an organization that classifies and publish a rank of the top 10 application vulnerabilities. And we use a notation or a score for these vulnerabilities using the common vulnerabilities and exposures convention, CVE. In bad bots, they crawl to scrape content, especially web assets and catalog, to obtain information that can be later used in other attacks. Now let's talk about the services we are going to dive deep today. We have 4 services, which are our focus for this session. The first one is AWS Network Firewall to protect the networks in AWS, which we call Amazon VPCs, virtual private clouds. We also are going to talk about AWS Web Application Firewall, or AWS WAF. This service protects web applications by allowing our customers to write custom rules or use managed rules from AWS to protect their applications. We also have the AWS Shield Advanced service, which is a service to protect applications against denial of service attacks, and AWS Firewall Manager to centrally configure and manage security rules across accounts and applications. What is an account in AWS? When we want to have resources in AWS, we have to identify ourselves using an email address and a credit card, and we create an account. And an account is a separate container of IT resources in AWS. But in large organizations, we can have multiple accounts that belong to a single organization, and we can organize those accounts hierarchically in a service called AWS organizations. So when we say that Firewall Manager can manage the policies, the security policies in a full organization across different accounts, we say that this service integrates with AWS organizations. With AWS Firewall Manager, we can have policies to manage AWS Web Application Firewall, VPC security groups, which are stateful firewalls that are applied at the level of network interfaces in virtual machines or in other resources in AWS. Also, we can protect different resources. We're going to talk about AWS Shield in some minutes with AWS Shield, and also we can have AWS network firewall policies administered by AWS Firewall Manager. In network firewall are firewalls that use deep packet inspection and also work as an intrusion prevention system. That is to differentiate network firewall from VPC security groups. Right? We are going to talk also in more detail about AWS network firewall in this session. What happens with VPC security groups? When we start creating different resources in an AWS account or across different accounts in AWS, we have the following challenges. First, we have to centrally monitor VPC security groups, and it is not always easy, especially if the amount of networks, subnets, and also network interfaces increase. So sometimes we put policies to permit different traffic in order for the applications to work, but these policies remain in the AWS infrastructure across several days, months, or even years. So it is important to manage policies to remediate over-permissive rules. We also have the challenge of continuous update of new and existing resources because once we create new resources, we make changes, and we have to make sure that these changes don't infringe our security policies. And finally, it is important to have a central reporting dashboard for all our policies in the organization. The next service we are going to explain is AWS Network Firewall. It is completely administered by AWS, so you don't have to install operating systems or firmwares and configure high availability for this service. It is completely managed by AWS. It offers flexible protection through fine-grained controls, and we can have consistent policy across VPCs and AWS accounts, especially using the integrations with firewall management. Some of the features of AWS Network Firewall are in regards to packet filtering. It uses application rules in open source rule format. We use Suricata as the common or open source format. And in terms of packet filtering, we can have stateless rules, stateful rules, also block and allow list for a large amount of IP addresses. We can have protocol detections and enforcement, and filtering, web filtering using fully qualified domain names on HTTP and HTTPS. In terms of visibility and report, we use the service in AWS to monitor different metrics across all of the infrastructure that is called Amazon CloudWatch metrics. We also use what we call VPC flow logs, which are mainly the headers of all the traffic that pass through the networks. And we have these logs to report what network firewall is blocking or allowing. We also can send the logs to the object storage service in AWS, which is called Amazon Simple Storage Service, or Amazon S3, or to Amazon CloudWatch logs, or through this one of the services to process real-time information in AWS, that is Amazon Kinesis Data Firehose. And as I told you before, we can have a central management for the network firewall rules using Firewall Manager, but also we can use Terraform templates and CloudFormation, which are infrastructure as code tools. CloudFormation is native from AWS, and Terraform is one of our technology partners, which also allow to deploy these templates not only on AWS, but also in other clouds or even on-premises environments. And we can have AWS Resource Access Manager, or AWS RAM, to share network firewall endpoints across different accounts or VPCs. In terms of AWS Shield, it is a service to protect against denial of service, distributed denial of service attacks. It can protect different services. For example, it can protect Amazon CloudFront Distribution, which is a content delivery network service in which we can have caching of the response of the request for the users. We also can protect hosted zones in Amazon Route 53. Amazon Route 53 is our DNS service in AWS. Also, AWS Global Accelerator. Global Accelerator is a service to have a point of entrance to the AWS network, the AWS Global Infrastructure Network, in different points of presence across the world. Also, we can protect with Chiral bands, elastic load balancing, specifically application load balancers, and elastic IP addresses also. In AWS Shield Advanced, we have protection beyond the network and IP layers of the OSI model, bringing protection for the applications. we have a special team of security specialists that help protect the applications. This team is called Shield Response Team, or SRT, and we can have access to that team to help assist in different events. At the end of the session, I'm going to tell you about a specific case in which we have activated these protections and what was the actions performed by the Shield Response Team. We can have event notifications in CloudWatch events to generate or to have the possibility to generate actions when an attack is detected by Shield Advance. And we can also use this integration to automate these responses, for example, for contention or remediation of the events. We also have, with Shield Advance, DDoS threat environment dashboard with incident details like type, time, size, duration of the attacks. We use an anomaly detection using AWS Web Application Firewall to baseline the behavior in our networks and can determine in that way using Shield when an anomaly over this baseline occur, and it can be done, can be seen as an attack possible event. So because of this, it is important to have these services, AWS Shield Advance, activated at least for 7 days in order to establish that baseline in the traffic and all other behavior of our resources. We can have also proactive event response by the Shield Response Team. And these two characteristics are important in Shield Advance in terms of costs, because if our customers have AWS Shield Advance active, we don't charge for AWS WAF nor for AWS Firewall Manager, and we can also have cost protection for scaling during an event. That is that if we see using Shield Advance that this scaling in resources is because of the attack, then all additional fees in which our customer incur, we return this cost for our customers, and they can have this solution for facing an attack. I'm going to show you some of the architectures in which we use Shield and also network firewall and WAF to protect different types of applications. These are the common cases that we see in our customers. First, we have the web application. This is the common use case across AWS. The customer use Route 53 and CloudFront. Remember, Route 53 is our DNS service. CloudFront is our content delivery network service. And we use WAF, Web Application Firewall, to protect the CloudFront distribution and also to protect an application load balancer, which have in the backend instances or virtual machines that are being balanced by this application load balancer. We can also protect static content that is hosted in our Amazon Simple Storage service, object storage, which can serve static web content for web applications. And in the icons, which we see this shield, we have these as Shield Advanced Protected Resources. Other case is protecting latency sensitive applications. In this case, we can use Global Accelerator to have better latency for our applications. And behind the Global Accelerator, we can have a network load balancer in this case, because this network load balancer is a service made for better performance as they use network traffic and not application traffic for balancing over a group of virtual machines. So this is another example in this case. Now we have serverless applications in which we use services that are more abstract. We call that way this kind of services. These services include, for example, AWS Lambda, in which we have all of the infrastructure required to run a code that our customers have, and our customers don't have to worry about servers, virtual servers, clusters, scaling, high availability. You just upload a code, and we at AWS put all of the infrastructure that is required to run that code. It doesn't matter if we need 1,000 servers or 2 servers to run the code. You just are optimizing the code, focused on the application and not on the infrastructure to run that code. So we call that kind of technology serverless. We also have here Amazon API Gateway, which is a service that is used to manage a very large amount of API requests to the applications of our users, and is also completely serverless, and a NoSQL database, in this case, a key value NoSQL database called DynamoDB, which is done for very high performance. So we have here an example architecture for a serverless application, and the way we can protect this application is using WAF, Shield, and also, for example, Firewall Manager to manage the policies from WAF and Shield in this case. And to protect on-premises applications, we can use different architectures. This is an example of an architecture we can use. In this case, we have here the on-premise infrastructure, our corporate data center, and we are using this as a CloudFront origin. So in Amazon CloudFront, we have this caching, and we can also perform security inspections using WAF at the edge without the need to go to the corporate data center. And we can, I can say, clean the traffic before it reaches the corporate data center. But in a hybrid infrastructure, we can have also resources on AWS. For example, as we saw in the first case, an application load balancer with a group of virtual machines behind this ALB. And we have here a connectivity between the two environments, the cloud environment and the on-premises environment. So these were examples of architectures in which we can protect resources that we have not only on AWS, but also on premises using the services that I explained before. We are now going to dive deep in AWS Web Application Firewall. This service can protect Amazon CloudFront distributions, AWS application load balancers, and Amazon API gateways. This is also a completely managed service by AWS. It's serverless. You just define the rules that will apply to the traffic, which goes to the protected resources. Or you can deploy this service without changing your existing architecture. You don't need to configure TLS or SSL or DNS. Also, in terms of the rules, we have rules administered by AWS and also rules from partners in the marketplace. These are technology partners for AWS WAF. For example, we have F5 and other partners that build WAF rules. We also have templates in CloudFormation. Remember, it's our infrastructure as code service, and also detections built in the service. These are examples of AWS managed rule groups. We use many of them in our implementations, mainly, for example, IP reputation list, which we can activate with just a click over here. Also, anonymous IP list, the core rule set, which protects again OSP attacks in the top 10. We use also SQL database. It's for protecting different relational database engines and protects against, for example, SQL injection attacks. And we have here other managed rule groups in AWS WAF. But also, if you want to just run the most used architectures for WAF, including a way to analyze logs that WAF generates, we have a template, a CloudFormation template that is ready to deploy. It's called AWS WAF Security Automations. And this template activates the main protections for WAF, and also have the ability to enable logging for WAF traffic and send it to our analytics tools for seeing all of the events that happened, and we can see then what is happening with the requests that are being processed by our web application firewall. We also have rate-based rules. These are important, for example, to block the distributed denial of service attacks or just denial of service attacks, and is very integrated with AWS Shield Advanced. So it is a good solution if we want to, in some sense, automate the protections using AWS WAF. Now we are going to see a Shield Advanced engagement case study. It was a case for a gaming customer that was experiencing a DDoS event. They had spiked request counts, 500 errors, and WAF requests. Also, the healthy resource count was dropping, and the impact on the services for the game that was affected was that the game connection URL, the password reset, and the forum support sites for this game were all failing to load. So our customer contacted the security response team for assistance. And what did the AWS Shield response team do? They enable WAF logging for the customer because our customer didn't have the solution or activated the logs manually. Neither of those things were done by the customer. The SRT also analyzed the WAF logs and detected more than 4,000 suspicious IP addresses to block. And then they created additional WAF rule to block that request without a cookie header. They identified false positives and added these IPs to a safe list to allow post requests with no cookie. The results, the request counts returned to a normal state. As we can see in this graph, also the 500 errors went to 0. And the WAF requests returned to normal behavior when they place the IP rule in the WAF. We invite you to see more information about the services I have told you. Shield Advanced, Web Application Firewall, Network Firewall, and Firewall Manager. You are seeing here also the pricing um, sites for each of the different services. Remember that if our customers um, activate Chill Advance, uh, we don't charge you for WAF nor for Firewall Manager. These services are, these two services, WAF and Firewall Manager, are included when you acquire Shield Advance. So with that, I want to thank you for your attention during the session, and invite you also to in some minutes we have remaining to answer some of your questions.
Thank you, Giovanni. I Let me first say good afternoon, everyone. I came into the session a bit late today. I came in after the session has started, but nonetheless, the session must continue, and so I am here to close out today's session. So once again, let me say thank you to Giovanni Rodriguez, as he would have been formally introduced, the Senior Solutions Architect at AWS Amazon Web Services. The
Thank you.
presentation, the presentation that you did was quite informative. It really gives an understanding as to the level of preparedness um, and the level of preparation Amazon puts into their products and services, especially from a security standpoint. So I have no doubts that persons on this platform that are already using the web services from Amazon or are considering to use those services are now a little more equipped to engage you, at least to guide them through any processes or any further conversation that needs to be had. Notwithstanding, I do know that many persons here also are not necessarily on AWS at this point, even if it is a consideration, they are not there as yet. You've highlighted quite a bit of security features that